Okay, so limited numbers today, but anyway. SWAT pack. The joys. Anyway, so today I'm going to try and get through Chapter 5 and Chapter 8, so I don't know if I'm going to have too much time for demoing, but anyway.
Yeah, I know that. Yeah.
So anyway, so Chapter 5 is network security and monitoring. Now, there's actually not a lot of new sort of actual configuration stuff in this chapter. It sort of just goes over best practices and considering security. And also a bit of monitoring, I suppose we haven't done a great deal of, but anyway. So we're going to look at LAN security, so how we can, we'll talk about common attacks and how we can mitigate most of those. We'll also look at SNMP, Simple Network Management Protocol. We'll look at how that operates. We'll look at the port analyzer, which we normally use as span ports. So, LAN security. So basically, with LAN security, so common security solutions using routers, firewalls, intrusion prevention, and VPN devices protect layer 3 up through to layer 7. But of course, layer 2 must also be protected. And so some of the attacks include CDP reconnaissance attacks. So I think I've said in the past, many organisations turn off CDP as soon as they've got the device. And I think actually more modern versions, the iOS CDP is off. So of course, Telnet, we've already spoken about where that falls over. MAC address table flooding attacks, VLAN attacks, and DHCP attacks as well. So we'll talk about several of most of those. Now CDP, as I said, Cisco Discovery Protocol is wonderful for fault finding. If you may be trying to troubleshoot a network that you don't necessarily have very good diagrams for, CDP can be a wonderful tool to sort of help you build a diagram of the network. But of course that means there's no security involved in CDP, and so that means that if it's running, other people can get a very nice idea of the map of your network as well. So, and so that information can be used as an attacker. So, reconnaissance normally, but it will actually, with further information, actually list what versions of the operating system are running on the different devices. And so, that's some nice information for an attacker. So, quite possibly you want to turn that off. So you can turn it off globally using no CDP run, or you can do it on a per interface basis using no CDP enable. Now, Telnet attacks. So basically there are brute force password attacks, and so it's just a way of hacking into your network with usernames and passwords. And of course, a denial of service attack is where you, of course, busy up or make the service fail so that valid users can't actually use the service. So, of course, the best solution is not to use Telnet. SSH is better. So, of course, it's encrypted. Strong passwords are always a good idea. And of course, we did look at those ACLs that you can do on the VTY interfaces, which are a very easy and good solution for it. And of course, having a more enterprise-based authentication service can also help you there. So using TACACS or Radius. Now MAC address table flooding. Now, so it's a common LAN switch attack. So basically an attacker sends fake source MAC addresses until the MAC address table is full and the switch is overwhelmed. Once the MAC address table is full, it starts flooding all packets to destinations. And so, of course, from there, every port will see every frame that's moving. It will decrease the performance of the network, and also if one of those hosts is compromised to that attacker, which it apparently is, they'll be able to see traffic that they shouldn't have been able to see. And so certainly not a great look. Now VLAN attacks, remember when we did your dynamic trunking protocols. First thing I said was, that's wonderful, but there are security issues. And so this is what we're talking about today. And so basically, what you can do is you can actually have a host pretend it's a switch and then actually set up a trunk port between it and the switch if it's in a dynamic mode. And so from there, it'll see the traffic of all the VLANs. And so, of course, again, that's the problem. And so they can talk to any VLAN, even ones they shouldn't be able to talk to. And they'll also see a lot more traffic than they would have otherwise. And so, again, certainly not a good plan.
Just like a quick question. How would you emulate a switch? Would you literally just put in the Cisco?
Oh, there's basically the right. All they really need to do is have some malware or some software that will actually just behave like a switch, and so send STP packets and and the DTP and all things like that. Yeah, so yeah. And so DHCP attacks. So there's a couple of ways you can go there. So spoofing attack is basically, if they've compromised the machine, they actually set that machine up to be a DHCP server. And quite possibly, because it's closer to the other hosts, it will actually respond quicker than the authorized DHCP server. And normally, first in, best dressed is how you go with your DHCP discover messages. And so, of course, the first thing they'll do is they'll set themselves up as the gateway. And so then every time you've got hosts that are talking to some other subnet, they'll be forwarding it to that rogue DHCP server. I'm going to say that it may well forward it on to the real gateway later, but all the traffic's going through it, and again, they can actually sort of see traffic they shouldn't be able to. Yeah. And so the other attack is more of a denial of service attack, where they basically send out more and more requests with different invented MAC addresses until all the addresses in the scope have been used, and so from there, valid hosts won't be able to get a DHCP address, and it won't work very well. And so basically it talks about how you mitigate those, and so there is actually a setting that you can do on switches for DHCP snooping, and then basically it will not accept a DHCP server being on any address or any port apart from the one that you say is a trusted port. And so that port that you have a DHCP server plugged into, you do need to configure it as being a trusted port, otherwise DHCP is not going to work very well. But at least there's only that one port that's trusted, and they can install the malware if they like, but it ain't going to be able to work. Now, of course, with that starvation attack, much the same as the previous one with the MAC address table, oh, sorry, not previous, a couple ago, port security is the way you do that. And so, of course, we covered that in CCNA 2, didn't we? So, again, limit the MAC addresses to 1 or 2 or a small number, and they're not likely to be able to do those attacks. So, how do we secure a LAN? And so, basically, strategies to help secure layer 2 of a network. Always use secure variants of protocols, so SSH, SCP, SSL. Use strong passwords and change them regularly. Enable CDP on selected ports only. Secure telnet access. Use a dedicated management VLAN. Use ACLs to filter unwanted access. And so basically with that, dedicated management VLAN, so no other hosts are on that one. Also, I think I might have mentioned it in the past, is like a lot of the labs we've said we'll set up VLAN 99, that'll be the management VLAN, that'll also be the native VLAN. You're actually better off to have a completely separate native VLAN to the management VLAN as well. So, and so I think I might have even mentioned dead VLANs and things like that, where you sort of create a VLAN, put all the ports in it, then you delete the VLAN, and so there's a whole pile of ploys you can do these things. Yeah. So there's IP source guard, prevents MAC and IP address spoofing. There's dynamic ARP, prevents ARP spoofing and poisoning. There's DHCP snooping, which we spoke about, with those trusted ports. And then port security, of course, fixes a lot of the problems as well. So mitigating MAC address flooding table attacks, as we said, port security is the best one there. So either statically specify the MAC addresses or do the sticky option. And so, of course, when the maximum number of MAC addresses is exceeded, the port will be, or either the packets will be rejected or the port will be disabled. So the VLAN attacks, basically, as I said, dynamic trunking while convenient. I don't know. It's not that much less work to actually use dynamic than it is to use static. It's not a great difference, actually, because you still need to get one of those ports into a keen to have dynamic trunking. So 1 port, 2 ports, not a great deal of difference. And so, of course, doing it manually on both ends of the trunk, it's just more secure. So DHCP attacks. And so, again, as I said, you set up the trusted ports with DHCP snooping, and then all the other ports are untrusted. And so, basically, the switch will block any DHCP offer and acknowledgement packets. Now, securing administrative access using AAA. So we've heard of AAA before. Authentication, Authorization and Accounting it stands for.
Yeah, you hadn't explained it. Well, I hadn't been explained.
Yeah, well, basically it's using an external server to do your authentication. Yeah. Well, actually it doesn't have to be, but that's probably the most common way that it gets used. Right. And so it'll always be username and password, as opposed to, the simple authentication systems are often just password. And so basically you connect to that router, it will then prompt you for the username and password. It will then send it off to that, typically the server-based authentication. So TACACS Plus is Cisco proprietary. TACACS is standardized, but it's fairly old. And so, embrace and enhance.
How does it? How is it TACACS? How is it?
How old? Oh, it's probably more than 20 years old. Yeah. But Radius is standards based, and while TACACS has some strengths,
Such as?
it can encrypt and authenticate a little more thoroughly. TACACS Plus can than Radius, but Radius, of course, is standards based, and you don't have to buy the Cisco tools to get it to happen. You can set up an Active Directory server to be a Radius server as well, so you can actually use Active Directory accounts. And so, it does work well. Of course, 802.1x is another solution, a bit like, you connect to wireless, you can use a username and password. Well, we can actually do that for wired connections as well. And so you actually authenticate to get layer 2 access, not just operating system access. And so, that is another solution. It's not commonly done, but I suppose it depends on your security needs. All right, so SNMP. So we're up to monitoring now. So SNMP has been around for a long time. There's been several versions of it. The first 2 versions, a lot of people called Security Not My Problem, because it was, again, plain text authentication and keys and things like that. So anyway, but it is really, so if you've set up SNMP, it can be such a wonderful centralized monitoring and configuration tool. It will do it all, actually. It's very, very cool. And so basically you need to have an SNMP manager, which is a computer that's running the software that keeps track of all your network devices, be they servers, hosts, switches, routers, you name it, printers and the like. And basically, on every managed device, you actually run an SNMP agent. And so that's sort of what does the communication on the device that manages communication to the manager. And then you also need to have a management information base, which is basically stores the data about the statistics, but also knows sort of what capabilities each device is that is being managed. And so it sort of has all that information about, what that device can do and things like that, and what you can configure on it. So SNMP agents that reside on managed devices collect and store information about the device. This information is stored by an agent in a local MIB. The SNMP manager then uses SNMP agent to access information within the MIB. And the SNMP agent responds to SNMP manager requests. And so basically you can do a GET, which will just read the statistics for that device. Or there's actually a set where you can actually change the configuration of that managed device. And so there's get request, get next request, get bulk, get response, and then set. So basically what that has been talking about is actually the manager runs all of the communication. And so the manager's in charge, which is fine, but basically, when a device senses a problem that you might want to report straight away, it just sort of stores it in that mode. While with SNMP agent traps, it's saying, all right, if something of a certain severity happens, tell the manager. And so it'll be told straight away. And so that's what the traps are. So that was actually an added feature that wasn't originally with SNMP. Okay, so basically, a network management station periodically polls the SNMP agents using the GET request. Using this process, it can collect information to monitor traffic loads and to verify device configurations. SNMP agents to generate and send traps to inform the network management station immediately of certain events. And so traps are unsolicited messages alerting the manager to a condition or event, such as improper user authentication or link status or whatever it might be. So the GETs, of course, as I said, are periodically done by the manager. Traps are done by the devices to the manager. Okay, so as I said, there's been the first two versions were a little bit ordinary, especially when it comes to security. While version 3, they sort of got serious with the security on SNMP. So a network administrator must configure the SNMP agent to use the SNMP version supported by the management station. So they're talking about 2C and 3 here, mostly. So SNMP version 1 and 2C use community strings that control access to the MIB. And so there's two types of access, read-only or read-write. And so, of course, read-only is just the statistics, while read-write is changing the configuration on the device. So management information-based object IDs, OIDs, uniquely identify managed objects, and are organised based on RFC standards into a hierarchy or tree. Most devices implement RFC-defined common public variables. Vendors such as Cisco can define private branches on the tree to accommodate their own variables. CPU is one of the key resources. It should be measured continuously. An SNMP graphing tool can periodically poll SNMP agents and graph the values. The data is retrieved via the SNMP GET utility. So basically, it's all standardized, but of course, every device isn't the same. And so the vendors can, of course, customize the management information base to suit their devices, basically. So SNMP version 3 authenticates and encrypts packets over the network to provide secure access to devices. And so there's 3 security features. There's message integrity and authentication. There's encryption, and there's also access control. So how do we configure it? And so basically, you configure a community string and access level using the SNMP server community command, and then you supply the string, and then you say RO or RW, whether it's read-only or read-write. You can document the location of the device using the SNMP server location, and so basically that just says, it's in the wiring cabinet level 3, whatever it might be. And so that's just handy for people. Oh, okay. Yeah, that device has got a problem. Oh, it's in the wiring cabinet in level 3. Great. I know how to find it now. And so, of course, you can also use ACLs to restrict access to just the network management station host. And so that can add more security again, so it can't be polled. So if someone does find your community strings, if they're from the wrong host, they're still not going to get the information. So that's certainly a good system as well. Now, syslog. So Kiwi syslog server is one of several solutions that supports display SNMP output. So have I mentioned syslog before?
Well, I know about it for Linux, but I don't think that you have. No.
So basically syslog, so I don't know if you've noticed, if you're logged into the console, maybe, if there's been a device that's been up for, the last 6 weeks or whatever, and you log in the console, you'll often get a whole plethora of messages of what's happened to that device since the last time someone logged into the console. Using the VTY, you don't actually get those messages unless you turn it on. Now, how often do we log into our routers and switches that are in the network? Especially using a console instead of VTY? Not that bloody often once they're running. And so with syslog, instead of having to plug in using the console, it will actually send those messages to a syslog server. And so that's not SNMP, but basically the Kiwi syslog server plays a bit of SNMP as well. So that's why they're talking about it, because, hey, it's a cheap solution. So basically the SNMP traps are sent to the manager and displayed on the syslog server. To verify the SNMP configuration, use show SNMP command. That will show you what is configured. You can also do show SNMP community command to show the community strings and ACL information. So that's a way you can verify it. So best practices. So SNMP can create security vulnerabilities, especially versions 1 and 2. And so ACL should be used to prevent SNMP messages from going beyond the required devices and to limit access to monitored devices. SNMP version 3 is the recommended version because it provides secure authentication and encryption. And so basically you can specify that with the SNMP server group command, what version you're running.
So SNMP version 1 and 2, they would probably be running legacy hardware, I'm guessing, or is it?
Yeah, well, yeah, it depends on what version of the network management station you got, as well as the hardware. Yeah. But version 3 has been out for quite a while.
Oh, okay.
So it's not as if it was released in the last year or two. It's been around for a while now.
Yeah.
And so basically, SNMP version 3, you will normally define an ACL. In this case, they're talking about a named ACL. And because, again, much the same as the VTY lines, because we know what we're accessing here, you don't actually need to have an extended one. A standard will do fine, because we already know what the destination is. And so you can configure the view to identify which OIDs the SNMP manager will be able to read. You can configure the group and version using the group. And then, of course, you can actually set up a user account as well. So the example configures a standard ACL permit admin. It is configured to permit only hosts from that particular subnet. And an SNMP view is named SNMP RO. And so basically from here, that's your ACL. That's the server view, that's your group admin, and that's using the ACL, and that's setting up the user account. Okay, now, switch port analyzers. So basically, port mirroring allows a switch to copy and send Ethernet frames from specific ports to another destination port. So basically, when would you use this? If you're using IDS. So basically, remember, you've got IPS, intrusion prevention. Normally, you don't actually run that testing absolutely everything, because you'll actually cause so much latency in your network.
Yeah.
It will be agonizing. But with IDS, so with IPS, you have it in line. So, incoming router, maybe straight to your IPS device and then straight to your network. With IDS, you can actually hang it off of a span port. And so, if you've got your tree coming down, you've got a switch there somewhere. For everything coming in, from that internet port, you can also send it to another port and to your IDS device. And it can scan absolutely everything. So if it gets over busy, well, at least it's not affecting your network latency. But it will report on absolutely everything that's going on, and you can then fine-tune your IPS to actually pick up the attacks that are happening. And so, IPS, you think of it and think, well, that's got to be better than IDS, but yeah, because it's in line, if it fails or does something nasty, well, you've killed your network. So, so you've got to use caution with IPS. And so basically, normally it's for analysing suspicious traffic. So it's a type of port mirroring that allows administrators or devices to collect and analyse traffic. Span is commonly implemented to deliver traffic to specialised devices, so packet analysers or intrusion prevention. But as I said, typically more IDS than IPS, but anyway. And so you can actually do local span ports, which is basically on the one switch. And so, you've got a source port. You've got you've got where the traffic is flowing, so between PC1 and PC2. And we've got this extra monitoring or span port, which is actually getting a copy of the traffic that's going through. And so it's an association between source ports. Three important things to consider when configuring span. The destination port cannot be a source port, and the source port cannot be a destination port. The number of destination ports is platform dependent. The destination port is no longer a normal switch port, only monitored traffic passes through that port. And there's also remote span. So we're analysing this traffic, but we're actually sending it to another switch will then be analysed there. And so basically, so it has two sessions. One session is used as the source and one session is used to copy or receive the traffic from the VLAN. The traffic for each RSPAN session is carried over trunk links in a user-specified RSPAN VLAN. Okay, so how do we configure it? And so basically it's called monitor session is the command. You give it a name because you can define more than one. Or sorry, you give it a number. And then so you do source interface, whichever one it might be. And then you also do the same command with the same number and you specify a destination interface as well. So that's pretty much it. It's not really all that complex. And you can actually do show monitor to show you what ports are doing what. So troubleshooting span. And so basically, to investigate a slow network application, the network administrator can use span to duplicate and redirect traffic to a packet analyzer such as Wireshark. Older systems with faulty mix can also cause issues. If span is enabled, a network technician can detect and isolate the end device causing the problem. Okay, so the summary is we've looked at how to mitigate some LAN attacks. We've looked into SNMP and we've also looked at span ports. Okay, that's chapter 5.